75266. So we are from group 5. So this is our member, which is Hani Hazwani binti Perlis, and Nur Hani Farahin binti Muhammad, Muhammad Ikhwan bin Latif, and the last but not least is Eric Colin anak Sulai. So we will present our presentation.
Assalamualaikum and hi everyone, my name is Ania Zoni binti Perlis with matrix number 73480. In this project, our group is planning to design the spike shoes which is suitable to be used in stadium track for runners. The spike shoes design has to be able to improve the speed of the runners whilst being safe. Therefore, one improvement that will be discussed in this video are the soles of the angle of the spike shoes. Based on this Villa table, we are describing the angle of soles of spike shoes and how we will improve the speed performance by changing the angle of soles. Angle of soles refers to the height differences between heels and forefoot, which is also commonly known as heel drop. Higher heel drop provide more significant length of stride, causing few strides of the same distance where the runners can conserve the energy, minimize the fatigue, while lower heel drop will minimize the impact, forces on body by promoting mid-foot and forefoot stride pattern, meaning the spike shoes will give natural and better balance form of running. To prove the improvement of speed by changing the angle of soles of spike shoes, our group has come up with few ways, such as doing calculation and analysis by establishing simulation to access product's target or performance. Next, to apply the knowledge of solid mechanics via finite element method to analyze the design improvement. For the next slides, I will briefly state the type of materials that our group chose for spike shoes design. For the upper part of the shoes, the material used is polyurethane, PU leather. The material is lightweight, provide better support, breathability, and has high impact absorption and resistance. For the soles part of shoes, we are using thermoplastic polyurethanes, TPU, because it reduces the damping effect, provide traction or anti-skid. The materials are also able to store energy as foot length and release it with each stride that will maximize the energy return while running, and it is lightweight materials. For the spikes part of the spike shoes, we will be using the stainless steel due to its skid resistance ability, improved acceleration, durable and customizable in terms of length and shape to meet the runner's specific needs.
Hello, my name is Muhammad Ikhwan bin Abdul Latif with the metric number of 73625. For 3D modeling, the following images are references used to make the 3D shoe. The bottom sole of the shoe was made following an image of a track shoe and the 3D spike from the 6mm length spike. The images were obtained from the internet. Thus, three 3D models were created which have the angles of 0 degree, 15 and 30 degrees, with all of them having 6 spikes on the bottom at the same place. The limitations of the models are the calculation would not use the exact angle from the model because the angle has a tolerance of plus minus 1 mm, and also the dimensions are also not accurate because it can change by 1 mm.
Hello, my name is Kelvin Shelby Anabalang and my metric number 75266. So today I will present you about the our sole. So this is our simulation for the sole. So this is the 0 degree sole, which is the flat sole. So this is our simulation, which is it is more stresses, it shows that it is more stresses to the center of the sole. So for this one, this is our second sole, which is for the 15 degree sole. So as you can see here, the sole, the forces, the stress is more it is more to the front of the sole, and then as you can see here, the critical of the stress is occur at the spike of the sole, which is this one. The red one is the stress that occur. So that's all from me. Thank you.
Hello guys, so I'm Iri Colin Anasulai, 73311. So here is the formula that we're gonna use to calculate the deflection or of the sole of the spike shoes. So here is the property of each material for the spike shoes component. And as you can see, this is the free body diagram for the sole, and the sole is from x1 to x2. The length is 15 centimeter, and then from point x2 to x3, the length is 4 centimeter, and then the last section is from point x3 to x4, which is equal to 14 centimeter. So on the top left side, we can see the free body diagram, the sketching, the roughly sketching of the sole. And then the force, which is the F, is occur on point x4. This is the formula that we're gonna use to calculate the deflection, which is deflection equals to PL cube divided by 3EI. So as for the calculation for 0 degree, which is the flat spike shoe, so here is the calculation for the spike shoes. We divided by into three sections. The first one is from x1 to x2, and then the second one is from x2 to x3, and then the third one is from x3 to x4. So this is the final value for each deflection. Uh, yeah. Next, for the 15 degree of the sole of the spike shoe, so this is the calculation. As we can see, the deflection is quite lower than the previous one, which is 0 degree. And then this is the deflection, the final value of each section. And as for the 30 degree of the sole of the spike shoes, here is the calculation that involve. Uh, each section shows different value of deflection. So as you can see, the middle part deflect about 1.287 times 10 to the power of negative 6 meter. So as we can see on the screen, the table shows the comparison between the deflection of each angle. So as you can see here, from point 1 to point 2, x1 to x2, it shares the same value of each different angle, which is 1.045 times 10 to the power of negative 4 meter. Same goes to x3 to x4. It also shares the same value, which is 3.098 times 10 to the power of negative 4 meter. However, on the section x2 to x3, as we can see here, the larger the angle, the smaller the deflection value.
I'm going to explain the cost analysis. In this project, we do cost analysis using break-even analysis. Simple theory of it is break-even analysis used to determine at which point does the sole of spike shoes generate profit equivalent to the production cost. Briefly, the fixed costs are the expenses that the company pays every month, which is office rental, utility bills, total salary of 20 employees, and others. As for the variable cost, Spike Shoes price for each pair is being estimated based on the maximum price set by the supplier, and total cost for shipping the shoes each is 7 ringgit according to the standard in Malaysia. The revenue is 80% increment of the variable cost as the company wants to make the maximum profit of it. Based on the formula for monthly record in terms of production unit, The break-even analysis is calculated as shown in the slide and graph presentation I'll produce, where the points made at 648 units monthly with break-even revenue as much as 105,624 ringgit. Theoretically, total production cost and revenue must be equal. However, some numbers are being rounded off to rationalize the value. Thus, it is proven that 648 units must be sold monthly to keep the business sustainable and better sale planning can be produced.
For summary, in conclusion, based on the simulation of ANSYS and the proven calculation that have been done, we are sure that our second design, which is one with the sole angle, make better spike shoes. Theoretically, when the spike shoes have an angle, it will make someone run on their toes. This will result to increase in running speed, as it will give more power to move forward. As our spike shoes are focused for the sprinters, it is discussed in a study that forefoot running allows momentum to move forward due to an increase of elastic energy within the calf muscles and ankle. However, our design can be improved in certain ways. Pyramid spikes are replaced with needle spikes. Pyramid spikes are suitable for beginners and suitable for most events, but needle spikes give a better grip and are suitable for all weather, especially when the track surface is rainy and damp. So spike shoes with needle spikes and professionals provide comfort in the interior of the shoes, give a better curve at the middle of the sole. This will improve ample support to the feet, which will give comfort and snug fit. Good cushioning and padding should also be installed to avoid blister and discomfort.